On to transformations in terms of stretches. So we've done translations and reflections. Now we are on to stretches. Stretches is making something bigger than it originally was. Meaning, if you have a rectangle of this size and you make it into a rectangle of this size, what is happening here is that you are stretching this rectangle wider, in obviously horizontally in this case. And if this rectangle becomes this, then what is happening? You're stretching the rectangle vertically. And so these are the two stretches that are there. Stretches in the y-axis are obviously going to be vertical, while stretches in the x-axis are going to be horizontal. Now, here what we want to do when it comes to stretches is everything that is of a certain y value. For example, let's just look at this right here. The y value here is -3. And once it stretches out, what happens is it goes down to -6. And you can take anything, for example. So if the y value was initially 5, it went up to become 10. So again, you multiply it by 2. So what's happening here is that every y value becomes 2 times that original y value, right? And obviously y is another representation of f of x. So every f of x becomes 2 f of x. And so if you want to convert this into its stretched equation, you just multiply 2 by the whole thing. So 2x squared minus 2x minus 3, it just becomes 2x squared minus 4x minus 6. And that's what happens when you stretch it in the y direction. And the way you show it generally is just a f of x. This will be a stretch in the y direction by scale factor of a. And that's how it works. Okay. When you're looking at stretches in the x-axis, remember the whole concept we used for translations in x, where we said moving to the right will be negative because we want the initial the input to be of a certain thing, right? To give us that output. And it's the same exact case for stretches in the x direction as well. So remember, it's horizontal stretch. And what's happening here is that originally we have this blue function where the 4, x being 4, is being put into the function and you get back f of 4, which is 5 in this case. Then what we want is we want to put in 2 as our x. Yeah, we want to put in 2. But what do we want? We want to put in 2 into the function, but we want back an f of 4 again. And so what do? We would multiply that input that we put in by 2 to put that into the function. And so even though we are having a scale factor of a half, meaning your 4 is becoming your 2. So your scale factor is a half. But what you want in your equation is that your f of x should become f of 2x. The same concept, similar concept to what we did for translation. Yeah, we want the initial thing to be 4 in terms of the input of the transformed graph. And so we want this to happen instead of what you would assume that you wanted this to happen, f of half x. Yeah, it's not this. It's going to be this because of, as I said, we want the input to be the same so that we get the output that is desired. And so here, f of x will become f of 2x, meaning every x value will become 2x. And so 2x squared minus 2x minus 3, which just become 4x squared minus 4x minus 3. And generally, if you have f of 1 over ax, yeah, that will be a stretch parallel to x-axis. So stretch of f of x parallel to x-axis, meaning horizontal direction, by scale factor of a. Yeah, because remember, we are inversing that scale factor. We had the scale factor of a half here. We inversed it. Half became 2. inversing a fraction, meaning you're reciprocating it, powering it by -1. And so you get 2. And that's what we used for our transformation. And so that's the general idea of stretches in x-axis. Quite similar to translations in x-axis, meaning you are inversing the thing, right? So if you want a general thing, your transformations in your y direction are straightforward. You want to go upwards, you will add. You want to go downwards, you will subtract. You want to make it longer, you're going to multiply it by a. You want to make it shorter, you're going to multiply it by 1 over a. Yeah, as you would expect. But for x, it will be the inverse. So what it is for y, it will be the opposite for x. So if you want to go to the right, you would assume it's going to be plus, but you use minus. If you want to go to the left, which is you're going to assume it's going to be minus, you're going to add. If you want to make it longer, horizontally, obviously, you will scale factor is 1 over a. You're going to make it shorter, your scale factor is going to be a. So it's going to be the opposite version of your understanding. It's an inverse transformation, right? It's an opposite to what the y was. And I've shown you why. Right? Now, some few examples. The first one being the graph of y equals to 5 minus half x squared is stretched with scale factor 4 parallel to the y-axis, meaning whatever y value there is, what will happen? It will become 4y, which means if y initially was 5 minus half x squared, what will become? 4 5 minus half x squared. And so this 4 times 5 is 20. 4 times negative half is negative 2 x squared. And that's going to be your new function, which is going to be your 4f of x. And this is going to be your new function. Then your next example, we are looking at stretches parallel to the x-axis. Remember, parallel to the x-axis, what we're doing is we're inversing that scale factor, right? So here, the scale factor is 1 over 3. What we will do, inverse it, and we get 3 instead, which means our x is becoming 3x, okay? And so we change all the x's we have for 3x, so 3x squared minus 2 times 3x plus 5. And so we get 9x squared minus 6x plus 5. And that's going to be our transformed graph, meaning after the scale factor 1 over 3 is applied horizontally. Okay. Then let's graph the single transformation that maps the graph of y equals to x squared minus 2x plus 4 into this graph right here. Now, whenever we see this type of question, what is important is we want to convert each of those equations into completing the square, because that will help us make everything easier. This example is a bit easier than what usually you get, yeah. But as a general rule of thumb, you need to convert it into completing the square, okay? And so what we will do here is, let's convert this into completing the square. And I've shown this before, so I'm just going to do it straight away. X minus 1 squared plus 3. And here, 5x minus 1 squared plus 3. Okay? And that's a completing square of both. Obviously, this is a different type of completing the square, meaning I made the changes to the x, but this is what you would get. And if you look at the transformation that's happening here, your x has now become 5x, and that's it. So x has become 5x. And we know when this happens right here, what's the case? There is a stretch in the x direction. So x direction stretch. And our scale factor is going to be the inverse of this. So 1 over 5. Okay? And the easier way of doing it, obviously this case allows us to make it easier. We can see straight away that there is no change to the entire equation because the constant stays the same, which means there is a change to the x. So x squared minus 2x plus 4 is becoming 25x squared minus 10x plus 4. What's happening here? The entire equation is not changing. So we know it's going to be an x transformation. X is going to become something. Then we just see. We want negative 2 times something x, let's just say ax, to become negative 10x. And we also want the same thing for that. So we want ax squared to become 25x squared. And with that, we can find our a is going to be negative 10x over negative 2x, which is going to be 5. And here, when we can do the same thing, a squared x squared equals to 25x squared, which means a squared equals to 25. And so a is going to be plus or minus 5. But from this, we get that it is positive 5. Okay? And that will give us the fact that x is becoming 5x. And then we can apply the same thing here, which will give us a scale factor of 1 over 5. And that's how you would find out what transformation is happening. Let's look at one final example where you have been given a graph and you have to sketch the transformation that we have been given. Now, if you look at y equals to 2f of x, meaning each y value is becoming 2y. The x is staying the same, meaning, let's draw it in red, the first one. And what's happening here is that for each x being the same, so when x is negative 2, it's always going to be negative 2. What's happening is that the y is becoming double. So y was 2 becomes 4. Y was 1 becomes 2. Y was 1 becomes 2. Here, y was like 1.5 boxes ish. It becomes about 3 boxes somewhere here. And then right here, negative 2 goes down to negative 4. Obviously, because you are still multiplying by 2, so it still goes down. And here, 2 becomes 4. And we have the exact same shape of the graph, where something like this. And what has happened here? We'll stretch it by a scale factor of 2. Okay? And now in the y direction. For the second transformation in the x direction, what's happening here is every x is becoming 2x. However, when you are looking at the stretch, what is happening is that you are making each x smaller. The scale factor is because we had said it inverses. Meaning, whatever x we have, the x becomes half of that for the same value of y. Meaning, if my x equals 6 gave me 2, now my x equals 3 will give me 2. Okay? If my x equals 4 gave me negative 2, now my x equals 2 will give me negative 2. Obviously, y does not change. If my x equals negative 2 gave me 2, now my x equals negative 1 will give me 2. You see? And if my x was negative 4, which gave me 1, now my x will be negative 2, which gave me 1. My x was negative 6, that gave me 1. It's going to be negative 3, that gave me 1. And so it will look something like this, where we have not made any changes vertically. It's still the same vertical size, but we have compressed it horizontally. We have made it from something longer into something compressed. Okay? And that is it for transformations in terms of stretches.